Good morning, sir.
Good morning, sir.
Good morning, sir.
So actually we will be revising graph theory. Okay, so I will write some questions. You please sit with pen and paper. You try to solve the questions and then you answer it. If you will not be able to answer, then I will solve for you. Okay, but try it. Okay, it will help you in exam. Okay, so we'll revise graph theory. So the first question, I will start with the basic. Okay, so I'm making a graph, and so like the graph is suppose this. So okay, let me ask first or part one. Okay, part one. So this is a graph, and other graph is okay. This is the loop. So the question I will ask in both the parts. So the second part. So tell me what is the size of a graph? Size of graph. Okay, so in part one and part two, you may answer separately. So like it is for part one, it is for part two. Okay, so we tell the answer. Size of the graph. You first write it, then order of a graph. Okay, and you have to check whether it is simple graph. So yes or no, you have to answer. Is it simple graph? Okay, so one by one, you may try. So yeah, tell me size of the graph one. I mean, in first part.
Sir, 2.
So what is definition of size? What is the definition of size? I mean, size of the graph means what?
The number of edges of a graph.
Yes, correct. So size means number of edges. So good. So for the first part, you have 2 edges. And what is the size in case of second part?
Same, sir.
But we have, it is not a simple graph. So do you define size only in case of simple graphs? Or what? Okay, so let me change this. So like this, yeah, now. Okay, now you tell. What is the size of the graph?
3.
Okay, 3. What is the order of the graph in first part? Okay, sorry. Yeah, order of the graph in the first part, yeah. So what is meaning of order?
Number of vertices, sir.
Right, number of vertices. Number of vertices. So here is 3, and what is the order in case of second part?
Sir, 3 as well.
It is again, yeah, correct. So you all please be active. Okay, you please answer. So now, okay, let me write the third part. So third part, if I write simple vertex only. So tell me, in the third part, what is the size of the graph?
Sir, I think first one would be simple and second one is a simple.
Okay, so we have 3 graphs here, right? This first part, second part, third part. There are 3 graphs. So you first tell me the size of the graph 3. 3 means third part.
1.
0.
Sorry, sir, 0.
So number of edges. So number of edges is 0. Okay. So here is 0. And then order of the graph in third part?
1, sir.
1. Fine.
1.
And now you tell which one is the simple graph from first, second, third part. What do you think?
Sir, second one is a simple.
Second one is simple. What about first one?
The first one is also simple.
First one is also simple. What about third? Third is a single vertex. So what do you think? Is it simple or not? So my question is, what is simple graph? So anyone please tell me the definition of simple graph.
Sir, a graph having no loops or multiple edges?
Right. So a graph having no loops or multiple, like it will neither contain loop nor multiple edge. So a graph having no loop or multiple edges. So a graph having no loop or multiple edges, so that is simple graph. So now you tell, read this definition, and based on this definition you try. So in the all three parts, first, second, third, which one is not simple? Now you tell, which one is not simple?
Sir, 2.
Why do you think 2 is not simple? So do you see any loop? Do you see any loop in any of the graph? No, there is no loop, neither in first part, nor in second part, nor in third part. So in any one of the graph, there is no loop and multiple edges. So anywhere you don't see any multiple edges. So that's why all are simple. So all three parts are simple. First, second, third, all parts are simple graph. Because whenever you see edge, multiple edge, or you see loop, then you will say it is not simple. Okay. So for example, like if I make earlier I made it like that, so this is a loop. Okay, so this is not simple. Or somewhere if I make like this, then this is not simple. Okay, so whenever you find multiple edges, so what is multiple edge? How will you define multiple edge? Yeah, so how do you define multiple edges?
So when two vertices are connected with more than one edge.
Or you can say like two or more edges have same pair of vertices or same pair of end points, same pair of end vertices, right? Okay, yeah. So if two or more edges have same pair of endpoints, then you call they are multiple edges. And how do you define loop?
Sir, edge with equal endpoints.
Right, edge with equal endpoints. So edge which have two equal endpoints or equal vertices as endpoints. So they are loops. Okay. So the next question I will ask. Okay, so in the graph, like this graph, so I was making this, suppose like this. So let me call it V1, V2. So V1 means vertex 1, V2 means vertex 2, V3 vertex 3, V4 vertex 4, and V5 vertex 5. So if I ask you, write the neighbors or adjacent vertices. So n of V1 I'm writing, the meaning is neighborhood of V1. So neighborhood of vertex V1 or neighbors of vertex V1. So neighbors of vertex V1, or you call it adjacent vertices of V1. So tell me, in the set you tell which are the vertices adjacent to V1. You call it neighbor or adjacent.
So V2 and V4.
Sir, V2 and V4.
Okay, so V2 and V4, fine. V2 and V4. So how do you define neighbors, or how do you define adjacent vertices?
Single vertex that is connected to two other vertices.
Okay, so you are defining based on this example. In general, how you define neighbor? Like neighbor of V1. So how did you get V2 and V4? So on which criteria?
Sir, if there is an edge between those vertices.
Right. If there is an edge between two vertices, then these two vertices are adjacent to each other, or they are neighbors of each other. Okay. So if you find an edge between any two vertices, then they are adjacent to each other, or they are neighbors of each other. Okay. So that's why you have seen that there is an edge between V1 and V2. That's why V2 is neighbor of V1, and there is an edge between V1 and V4. So that's why V1 and V4 are adjacent. Okay. So similarly, you tell neighborhoods of V2. Neighbors of V2.
V1 and V3.
V1 and V3. Okay, and so neighbor V2. V2 means V3 and V1. Yeah. Neighbors of V3.
V2 and V4, sir.
V2 and V4 only. Yeah. Okay. And neighbors of V4.
V3, V5.
V5.
Only two.
And V1.
No, sir, V1, sir.
V1, V3, 5.
Yes. So V4, V1, V3, V5. V1, V3, V5. Yeah. And the last is neighborhood of V5. Neighbors of V5.
So V4.
Only V4.
E4.
Only. Yeah. Okay. So these are questions based on neighbors or adjacent. Next is okay. So next question is let set S I'm giving. S is a set 2, 3, 5, 7, 9, 12. Okay. And the question is construct a graph G such that okay such that V1 V2, so V1 V2 are vertices, so S is a set of vertices. Okay, such that okay, so first let me write, so the vertex set of G is S and vertex of V is S and V1 V2 belongs to E of G. So but like V1 and V2 are two vertices, so joining V1 V2 there is an edge, so V1 V2 will construct an edge in graph G if so the condition is V1 plus V2 it belongs to S, or mod V1 minus V2 belongs to S. So S is a set of numbers 2, 3, 5, 7, 9, 12. So this is the condition. There will be an edge between V1 and V2 if V1 plus V2 is in S or V1 minus V2 modulus is in S. Any one of them can happen. In that case, you will make an edge between V1 and V2. So they are asking you, okay, and for, so this holds for V1 comma V2, obviously they will belong to S. V1 V2 are vertices because it is saying S is a vertex set, so they want to say S is a vertex set. So question is, tell me the size of the graph. So the size of the constructed graph is, tell me. So this is a numerical answer type, you tell me the number you get. So everyone please try it. So when you will construct the graph, so what will be size of the graph?
Sir, is it 4?
Okay, so I will, so option A is 4. Others try. So like if they will, people will give different answers, I will make that option, and others will have choice to choose them also. So you think, suppose in exam you have this type of questions, suppose. So you will have 4 options there. So you know the pattern of examination is going in online mode.
So can you erase option A and make it as 5?
Okay, no problem. So I make other option 5. Yeah.
Sir, is it 3?
Okay. So I don't know the answer. I will also solve for you now. So you just solve it and tell the answer. Then I will solve for you. So how are you thinking? Vertex set is S. So how many vertices it will have? So if I ask you the number of vertices in that graph, or order of the graph is what? Order. So how many
So
vertices?
6.
Yes. So you know vertices are named as 2, 3, 5, 7, 9, 12. Yeah. So if I construct the graph, suppose, so see, 1, 2, 3, 4, 5, 6. So the names we have to keep it like 2, 3, 5, 7, 9, 12. So we have to name the vertices as. So like instead of writing v1, v2, v3, v4, v5, v6, we have to name the vertices as 2, 3, 5, 7, 9, 12. It is given here. Okay. So it is given here that vertex set is set S. And now v1, v2 will join to make an edge if v1 plus v2 belongs to S. So now you check here. So let's start from 2. So will you join 2 and 3? Yes or no?
Yes.
According to this condition, so 2 plus 3 is 5. 5 is in set S. Yes. So we will join. Okay. And now will you join 2 and 5? Check the condition.
Yes, sir.
So you will join v1, v2 if v1 plus v2 belongs to set S, or v1 minus v2 modulus belongs to S. So you will join 2, 5 because 2 plus 5 is 7. 7 is in S. So yes. Will you join 2 and 7?
Yes, sir.
So 2 plus 7 is 9. 9 is in S. Yes. So you will join it. Will you join 2 and 9?
No,
No,
sir.
sir.
So there are two conditions. You have to check both. So according to first condition, 2 plus
Yes, sir.
9 is 11, not in S. But according to second condition, 2 minus 9. So 2 minus 9 modulus is there. So 2 minus 9 modulus will be 7. As 7 is in yes? Yes. So this condition holds. So yes, you will join. So there are two conditions, either this or this. So you will check both. If anyone satisfies, then you will join. If none of them satisfy, then you will leave. So v1 minus v2, 2 minus 9, 7. 7 will belong to S. So that's why you will join. Now will you join 2 and 12?
No, sir.
So 2 and 12 you will not join, because 2 plus 12 is 14, that is not in S, and 2 minus 12 mod will be 10, that is not in S. So you will not join 2 and 12. So we work for vertex 2. So 2 का काम हो गया, अब next vertex पे आते हैं, ठीक है? So let's come to 3 now. So ना, you will not go backward. Backward means you will look after 3. Okay. So now you think about 3, 5. So what do you think? Would you join 3, 5?
Yes, sir.
3 plus 5, 8. It is not in S, but 3 minus 5 is 2. That is in S. So you will join. Yes. Now will you join 3 and 7?
No, sir.
So 3 plus 7, 10. That is not in S. 3 minus 7, 4. That is not in S. So you will not join. Will you join 3 and 9?
Yes, sir.
Yes. So 3 and 9, 12. 12 is in S. You will join. Will you join 3 and 12?
Yes, sir.
So 3 plus 12 is 15, that is not in S, but 3 minus 12 is 9, that is in S. Yes. So we will join. And now हमने है ना 3 का काम हो गया. So we will go next. So 5. और 5 के आगे सोचेंगे. आगे means so now will you join 5 and 7?
Yes.
Yes, sir.
So 5, 7, 12. Yes. So now will you join 5 and 9?
No, sir.
No. 5 plus 9
No,
is
sir.
14. That is not in S. 5 minus 9 is 4. That is not in S. Will you join 5 and 12?
Yes, sir.
So 12 plus 5 17, that is not in S, but 12 minus 5 is 7, that is in S. So yes. Now 5 का हो गया काम. अब 7 पे आते हैं. You will look after 7, okay? So just you will think about 7 and 9. Would you join 7 9?
Yes.
So join 7 9. And would you join 7 and 12?
Yes, sir.
So 7 plus 12 is 19, but 7 minus 12 is 5. So 5 modulus I'm taking, okay? So we'll join it because 5 is an S. Now you will come to next element, that is 9. So would you join 9 and 12?
Yes, sir.
Yes. Yes. And that's all. So there is no element after 12. So that's all. Now you count the number of number of edges. So number of edges is the size of the graph, right? So you count the number of edges. So you count carefully and tell me what is the number of edges.
So 14.
Okay. This formula you must be knowing. This is called fundamental theorem of graph theory. So I will use it to count the number of edges. It may be difficult in counting manually, so I will use this formula. Fundamental theorem of graph theory.
12.
So
So 12.
one option came 12, 14, second came 12. Yes, any more? You count the number of edges.
12, sir.
So okay, so what can you do? You count the degree of each vertex. So degree of 2 is 1, 2, 3, 4. So 4. Degree of 3, 1, 2, 3, 4. Degree of 5, 1, 2, 3, 4. Degree of 7, 1, 2, 3, 4. Degree of 9, 1, 2, 3, 4. And degree of 12, 1, 2, 3, 4. So what I did, I find the degree of each vertex. This I'm finding here. So I got it what? 24. And so 2e is equal to 24. 2e is, e here is number of edges. E I'm taking number of edges. Okay. So this is a formula. 2 times number of edges is equal to sum of degrees of vertices. This is called fundamental theorem of graph theory. So that will help you to count. Otherwise you may count manually, counting. So it may be calculation mistake. So 2 is 24. So e is 12. So now you have 12 number of edges. So number of edges is 12. Okay. So the answer for this question is 12. Okay, so if they ask you such type of questions, so you have to think a lot. Okay, so next question. So see if anyone has doubt, you may ask the question related to this question. Okay, so first of all, you tell me. So I think no doubt in this. So what is the definition of complete graph? So what is complete graph? So what is complete graph? How do you define complete graph? So what is complete graph?
Every vertex is connected by a different edge.
Okay, you are trying good, but you have to Put in words.
Every vertex is connected to the other vertices.
Yes, so you may call it like every vertex is adjacent to all other vertex, all other vertices. Okay, so every vertex is adjacent. So adjacent is connected. They have an edge. So every vertex will have an edge with the all other vertices. All other vertices. So you call that graph as simple, a complete graph. And what is notation? Do you follow? So what notation do we write for complete graph? I mean, what is the notation, standard notation for complete graph of order n? Complete graph of order n. So what is the notation? How do you denote it? Like if I want to write complete graph of order n, this is in word. Mathematically, what do we write in symbol? No one knows?
Sir.
Right, kn, yeah. So this is kn, okay? Complete graph of order n. So there are n vertices and each vertex will be adjacent to the all other vertices. So that is the complete graph of order n. Okay, so for example, so like this is k2, complete graph of order 2. Okay. This is k3, complete graph of order 3. So each vertex is adjacent to the all other. Okay, so this is k4. Okay, so each vertex is adjacent to all other. So this is k5. Okay, so the question they are asking. So first of all, tell me what is size of this graph k2? Size I'm asking. Size of graph k2.
1,
1. What is size of k3?
3,
3. What is size of k4?
6.
6,
6. What is size of k5?
So 8.
Okay, so 5c2. 5c2. No, it is not it. Check.
9,
No.
8.
It's 10.
10.
So
Yeah.
10.
So I told you the way, this way you can use. So like when you're confused in counting the edges, you just count the degree of each vertex and divide by 2. You just add the degree of each vertex and divide by 2. So you will get the number of edges. So for example, like you are facing difficulty here. So see, this vertex have degree. So vertex have degree 1, 2, 3, 4. 1, 2, 3, 4. Well, I mean each vertex have degree 4. And there are 5 vertices. So 5 4s are 20. So degree sum is 20. And degree sum upon 2 is the number of edge. So degree sum is 20. So 20 upon 2 you will get 10. Again here each vertex has degree 3. So 3 4s are 12. So degree sum is 12. So number of vertexes degree sum upon 2. So that is 6. Here degree sum 2 plus 2 plus 2. Degree is the degree of vertex means how many edges it has, or it has a connected edges to other vertex. So that is degree sum is 6 here. So 6 upon 2 3. Okay, but what is general formula? So like you considered that k2 has size 1, k3 has size 3, k4 has size 6, k5 has size 10. So can you tell me what is will be the size of k6? So question is what is the pattern? How will you note the pattern? So this was K2. So 2 C like Kn na, it is K2. So 2C2. 2C2 will be what? 1? Yes. K3 is 3. So 3C2. You know NCR? Anyone tell me the formula of NCR? NCR, permutation of R or permutation of n object, sorry, combination of n object taken R at a time. So anyone tell me the formula of NCR or N choose R? So whatever notation you follow, and somewhere you in book you write this. So please tell me formula for NCR. C4 combination. So number of combination of n object taken, n different object taken R at a time.
Sir, n factorial by r factorial into n minus r factorial.
Yes, correct. So n factorial by r factorial, n minus r factorial. So now here is the word factorial. So what is factorial? So n factorial means 1 into 2 into 3 up to n. Okay, like 4 factorial is 1 into 2. हैं? पता नहीं, मैं फोन से ज्वाइन किया हूँ फिर. अच्छा, Redmi 9i एक्टिव होगा, चाहो तो चेक कर लो आप. सेम पासवर्ड 1 to 9. 1 to 9. 1 2 3 4. Okay, sorry, I got disconnected from internet. So we were here. Okay. Yeah. So is it same section I was teaching in?
Yes, sir. Yes.
Yes, sir.
Okay, okay. So we were here. We were counting the size of the complete graph. Okay. What I was telling, In K2 the size is 1, so 1 is actually 2C2. In K3 the size is 3, it is 3C2. In K4 size is 6, that is 4C2. In K5 size is 10, that is 5C2. Okay. Okay, so now can you tell me the size of the graph K6? So size of the graph K6.
Sir, I have a question.
Yes, yes, ask.
Sir, what does that C stand for?
Combination. You
Sir,
may
can you
write.
please explain that once again?
Yes. So combination. So permutation and combination you must have seen in your intermediate classes. So what happens, like for example, you have 5 friends, suppose, and you want to choose 2 of them. So there are how many different combination you can make. Okay, suppose in a party you want to go with the only 2 person and you have 5 other friends, so you want to choose only 2. So how many different way you can do that, or how many different combination you can make? Okay, suppose 5 of your friends are A, B, C, D, E. So you can choose AB, or you can choose AC, or you can choose AD. So like that, if you count this manually, then it will be too much time taking. So like the formula we have 5C2. So 5C2 you will have 10. So you will have 10 ways, and you may write all that. So you have n objects and you want to choose r of them. Okay, n different objects. You have n different objects and you want to select or choose r of them. So you will have number of way Ncr. Okay, this is a formula. तो हमारे पास n चीजें हैं, डिफरेंट चीजें, मुझे r सेलेक्ट करनी है, उनमें चुनना है r को ही. तो कितने अलग अलग तरीके से हम चुन सकते हैं, उसको बोलते हैं Ncr. ठीक है. सो ये फॉर्मूला होता है, इसका फॉर्मूला ये आता है n फैक्टोरियल अपॉन r फैक्टोरियल माइनस r फैक्टोरियल, और फैक्टोरियल का मतलब यहाँ लिखा हुआ है. सो द फॉर्मूला आई वांट टू कन्वे हियर इज दैट, अब K6 है, सो K6 में K6 का तुम फाइंड करो. सो फॉर्मूला होगा K6 का 6C2. अब बताओ 6C2 की वैल्यू क्या आएगी, इस फॉर्मूला का यूज करके बताओ मुझे. मतलब K6
15.
कितना आएगा?
15.
तो देखो एक शॉर्टकट फॉर्मूला भी है NC2 का. सो NC2 इज n इंटू n-1 अपॉन 2. सो इसी फॉर्मूले से आता है, तुम यहाँ पुट करोगे तो उससे ही आ जाता है. NC2 r की जगह 2 रख दो तो आ जाएगा दिस. तो n को अब 6 रख दो तो 6 इंटू 5 अपॉन 2. So it will give you 15. So like size of the graph K6 is 15. So in general, if I want to say you, so size of graph Kn, okay, Kn means complete graph of order n. So size of graph Kn, complete graph of order n is n choose 2, and sometimes we call choose or something NC2 or X is combination. There are two concepts, permutation and combination. So in combination, order doesn't matter. For example, you select your friend A and B with you, or you select B and A with you, both are same. So that is combination. Permutation is how different? So like permutation has different concept. For example, you write 1 2, it is 12. You write 2 1, it is 21. So both are different. 1 2, the digit you are selecting, 2 digit number you are making. So if you write 1 2, it is 12. If you write 2 1, it is 21. So 21 and 12 are different, but AB and BA are same in case of friends. So where order matters is permutation, where order does not matter is combination. So that is different concept in permutation combination. You must revise it. You must have done all that. Okay. So C means combination. Combination means order does not matter. So that concept it come from. So just you need to know here formula of NCR. That's all. So I was telling about background of NCR and what is mean a combination. Combination means order doesn't matter. Permutation means order matters. Okay, so NC2 formula you will have n into n-1 upon 2. So in exam you may be asked based on this formula, you have to remember this. So they may ask you what is the size of K6, it is 15. So you just remember this formula, then you put whatever they ask. What is size of K10? So suppose if I ask you the size of graph K10, so what will be the size of graph K10? So tell me.
45.
45. So if you use the formula, so it will be so this is 10 into 9 upon 2. Okay, so 90 upon 2, this is 45. Okay, so okay, so size will be 45. Size is number of edges, and in the graph K10 will be 45. Okay, so simply like for Kn, if you write, so order means number of vertices, that is n, and size we write, so that is n choose 2. So n choose 2 means n into n minus 1 upon 2. Okay, so this is size and this is order. For Kn means complete graph of order n, complete graph of order n. And complete graph means each vertex is adjacent to the all other vertices. Okay, so next concept comes complement. Okay, so after complete graph, there is a word complement graph. Okay, so complement of a graph, like not complement graph, you may write complement of a graph. Complement of a graph. So okay, for example, if I give you this vertex, so let me call it v1, v2, v3. Okay, so what will be complement of this graph? So like, okay, so just for size of this graph, I'm calling g. So size of this graph g, size is number of edges, so here is only one edge. So what will be size in g complement? So I write g bar. Complement means g bar. Okay, so can you tell me, so since we are doing revision lecture, so first I'm asking you the question, so what will be size of g bar?
1.
2. So how we find the complement? So this is v1, v2, v3. So when we are finding complement, so vertex set remains same, and edge set we are taking complement. So for example, like v2 and v1 have already edge, so there will not be edge in complement. And now in case of v2 and v3, there is an edge. So here, sorry, there is no edge here. In graph G, there is no edge between v2 and v3. So in G complement, you must have edge between v2 and v3. Here between v1 and v3, there is no edge. So in complement, you have to make. Okay, complement you are taking. So in G, if already edge is there, so you will not make an edge in complement. But if edge is not there in between two vertex, so in complement, you will make the edge. So this is complement graph of that. Okay, so like here if I write, so we also write vertex set of graph G. So we may write v1 comma v2 comma v3. We write vertex set of graph G complement. So size was 2, size is number of edges, and v1, v2, v3. Edge set of graph G. So edge, how many edges you have? Only you have v1, v2. This is one edge. Only one edge you have. And if I write edge set of G complement, so G complement you have edge v2, v3, v1, v3. Okay, v2, v3, and v1, v3. Okay, so this is, so how do you define the complement? If you want to define the complement of a graph, anyone would like to define? So how do you define the complement of a graph? Yeah, how will you define? So the if you want to define, So G bar is the notation for the complement, and the first thing is vertex set of G complement is same as the vertex set of G. And second, if like UV, so U and V are two vertex. If UV belongs to G, so UV is an edge in G if and only if UV will not be an edge in G. So 1 minute, here you have to write EG. EG means edge in G. So it will not be an edge in G complement. Okay, it will not be an edge in G complement. Okay, so UV is in EG, then UV will not be E of G complement. That is the graph. Okay, so this is the definition for the complement. So how will you construct the complement of a graph G? Okay, so I will ask you one more question. So the complement of graph is, so I'm giving you option. Okay, so one option is, okay, this one, option B I'm giving you, this, and option C you have this, and option D you have yeah. So tell me.
Sir, B.
Sir, D.
The
Okay,
option.
so B for Bombay, D for Delhi. So there are two options, you have, I mean, some of you have selected. So which one?
Sir, D.
D
Okay,
for Delhi.
D for Delhi. Okay, so like see, you have what? This let me name the vertices. So like call it V1, V2, V3, V4. So here also we make V1, V2, V3, V4. Okay. So now, so V1, V1, V2, V3, V4. So what will do? So see, here you check. There already is between V1 and V2, so you will not make is there. There is age already between V2, V3, you will not make there. There is already age between V1, V3, V4, you will not make there. But there is no age between V1 and V4, so you will make one there. Now you have to also see the others. Like there is no age between V1 and V3. V1 and V3. So you have to make one age between V1 and V3. There is no age between V4 and V2. So you have to make one. Complement we are doing. So age नहीं है तो यहाँ age लगाना है. वहाँ age है तो यहाँ नहीं लेना है. Complement उल्टा. ठीक है? So this is the complement. So D option is correct option. Okay. So D is the correct option. So whenever you see that between two vertex there is no edge in G, so you will have to make an edge in G complement, or vice versa. Okay. So I think I should stop here today. We'll continue this in the next class. Okay. So that's all for today. Thank you. Yeah. Thank you.
Thank you,
Thank
sir.
Thank you, sir.
Thank you, sir.